Right, so, um, yeah, I'm trying to do a mechanistic explanation of like super small neural nets. And I tried to do this particular one. Anyway, I think I figured it out, and also maybe how to explain it. So, I'll just jump into it, then, because then I can move on to a different neural net. And, yeah. So, it's not entirely clear. Yeah, okay, so I'm gonna talk about the first layer features. And, yeah, we will support most of the things I'm saying, with reference to the weights. So this is like the target function. It's like a 4-dimensional binary input, and we're trying to separate the blue rows from the red rows. And we trained a neural net to do this, and then we're trying to understand like what the neural net is doing. And here's what it's doing. Yeah. So like we're gonna look at the layer 1 weights. And like, yeah, they're just direct kind of features. So this first row corresponds to this column, and basically it's saying you're going to have a red if you match 2 out of 3 of the high magnitude like sign patterns. So if you have like blue-red or red-red in particular. Yeah, so it's doing a majority function. So if we just look at some of them, I already forgot what it is. Blue, red, red. Okay, so this matches on the first 2, so it's red. Blue, red, it's red. And then if you go down like down here to a blue row, blue, red, it mismatches on 2. So therefore it's 2. Okay, so it's doing like a it's doing like a majority computation on the first 3 dimensions. And if you look at the correlation, like it actually correlates kind of well with the actual target function. So yeah. So that's kind of amazing that like gradient descent can find that. Because I think, yeah, I mean, like if you try to solve this problem by yourself, you're like, okay, what do all the red rows, because this is a random function, so you're just like, okay, what do all the red rows have in common that is not shared by the blue rows? Also, you can only talk about predicates that are like expressible as a dot product with a weight array. Anyway, so yeah, so like that's the majority function. The other 3 columns are like a lot easier. So like the second column is just looking for blue and blue on those 2 columns. So these red rows for the second column, they'll have blue and blue. The third column is kind of like inverted. Yeah, I think because it has a positive bias or something. I'm not entirely sure, but basically it's just saying, do you not have 2 reds in your input? And then the final column is the same thing, but it's looking for a red blue. So it's saying like, do you not have red blue? Or no, it's basically saying like, do you have blue red? And if you do, then you're blue. Yeah, I'm not really sure how to express that logic, but it makes sense. It's just looking for this one feature. Okay, so like those are all the first layer of features. You have like the majority thing, and then you have like this two blue column thing, and then you have the two things in the middle, and then you have like the blue red thing. Okay, so like yeah, the yeah, so like the first layer has collapsed. Yeah, it's just right. It's just collapsed a lot of the points. Okay, so now I think we're gonna go backwards, keeping in mind the first layer features. Yeah, it would also be interesting to like rerun the same function. But anyway, okay, so we'll try to go backwards now. So let's look at the weights for the last layer. So they're like red, blue, red, blue. So based on that, based on them being red, blue, I would claim that this here, like these two columns, are sufficient to output a blue because it's like red, blue, so both of those are multiplying a positive by a negative, and then you're adding, so you get a negative. Yeah. Okay, yeah. So I'm just gonna say, right, so the last layer is saying if you have a blue in this column and a red in this column, then your output is a blue. And then like this other stuff, it just kind of reinforces that, but I'm going to ignore those columns for economy of explanation, even though it's already completely not followable. But that's cool. So anyway, what we want to talk about is what makes this column red. So this column is red. This is like a layer 3 activation because it's an input into layer 4. So this is where this column is being produced, and so we can look at the weights for that column, which is like this red, red, blue, red situation. And so the way I'm interpreting that, possibly incorrectly, although like it does work, is I'm interpreting this as because like in the inputs I don't think you really have this thing going on. Yeah, so basically I'm interpreting it as like if the two outer columns agree, then that controls. That's not even true though, because like if you add those, you get like 2.7. Well, I mean, like if you look at it, it's been, okay, so like it's putting huge weight on column 2. So yeah, so like it's basically copying column 2 over. Remember, column 2 is the two blue feature going on. So it's copying column 2 over, and it agrees with column 2, except for on these rows, like going up, because column 2 is a blue here, and this feature is a red. So basically what it's saying is like, I'm red if the input has column 2, if it has these two blue features, or, right, it's a disjunction, or the two outer columns are both red. So yeah, so it's saying like, so this outer column, this last column is saying like I'm red if you have two blue features, or you have this, the two outers are both red. You have both of the outer features. And if you look at that, like it correlates almost perfectly with the target function, except for this one exception, which is a red. So, okay, so going back to this output, we're looking for blue-red, like we're claiming that's sufficient to output blue. So the red is this, like that weird logical expression, like you have the two blue columns, or you agree on the majority, like with the first feature, like, and also you don't have blue-red. So anyway, that's the, yeah, okay, so let's talk about this blue column, because then maybe we can, yeah, I mean, at the end of the day, we're kind of like trying to give like semantic interpretation to like a random collection of binary strings, which is bad. You shouldn't try to do that because it hurts. But I mean, like gradient descent figured it out, so it's like we have to understand what gradient descent did. I mean, we don't actually have to. It doesn't. But anyway, okay. So let's talk about this blue column. I mean, if you just look at this column, it's basically saying like I'm blue everywhere, except for like these two red points. In particular, this red corresponds to the exception, right? So it's kind of doing like some error correction. And if we look at the weights for the third column, it has two big reds and then a blue. And so if we apply that to the inputs, it's canceling on all of these inputs. It's not canceling, it's like reinforcing on this input, like red, this is like red. And then it cancels everywhere else. Although, like, for some reason I don't understand, it picks up this blue and then makes this kind of red. Yeah, I don't really know how to interpret that, so we're just going to ignore that. But but basically what it's saying is it's saying like it's saying like, hey, we have this fourth column that perfectly correlates with our target function except for this one input. And so we're going to tag that one input. And the thing that makes that one input unique, literally compared to every other, input, is that it agrees with the majority. Like, it has two reds in these two columns. So it's saying it's the unique input that agrees with the majority feature, which again was blue, red. So you have blue and red. So it agrees. And also, it has the two blue stripes, right? So like that's like the one that uniquely identifies this one input, which is the error input. And so logically, what is happening here is this thing is saying like, you are a blue output if this column is red, which again is this or, like it's saying you're red if you have these two blue columns, which is correct except for this, or you have a and over the two outer columns. And that, yeah, like that and over the outer columns perfectly corresponds with this chunk of blues. And the two blue stripes almost perfectly corresponds with this chunk of blues. And so we have like error correction on that one input. And yeah, and so then it does blues. And yeah, we're going to take that as we're just going to say that's a good explanation for this neural net. I mean, the reds are kind of similar. Like, in fact, this first column, like, so we're saying like you need red, blue here. This first column is the negation of this column. Like the weights are literally, they're almost the same magnitudes, and but they're the exact opposite sign pattern. And yeah, we're just gonna ignore this column. But anyway, so yeah, I'm not sure that was yeah. I mean, I thought it was cool how like you're literally giving it like random binary strings, and then it's just like, yeah, the blues, they all have this blue column feature, and or they also have this conjunction feature. And yeah, I mean, because that's like those are kind of like discrete features which you would like, want to do like a genetic algorithm or something, but it's like, no, gradient descent kind of finds it. Okay, anyway, yeah, I'm gonna do a different function. And but yeah, I had to record this one for posterity because it took a while, and I have to relaunch my browser. So, let's see.